Hi guys, welcome to another video. This is Quantitative. In this video I'm gonna show you the normal distribution, the standard normal distribution. Now I'm gonna do question 2.1. Assume that the mean life of a particular brand of a car battery is normally distributed with a mean of 28 months and a standard deviation of 4 months. Now, for a randomly selected battery, what is the probability that it will last between 30 and 40 and between 30 and 34 months? 30 and 34 months. Firstly, the notation of a standard normal distribution is like this. So you differentiate the normal distribution when in the statement you are given a mean and a standard deviation. As you can see, the mean and standard deviation is given, which means this is a standard normal distribution. Now, the formula of normal distribution is equal to Z is equal to X minus mu over the standard deviation. X minus mu over the standard deviation. Mu is the mean. So the mean is 28 months. Then standard deviation is 4 months. So we are given the mean and the standard deviation in months. Question A. For a randomly selected battery, what is the probability that it will last between 30 and 34 months? Between 30 and 34 months. Which means P into 30 is less or equal to X, and X is less or equal to 34, which means between 30 and 34. Now we are going to use this formula to calculate Z. The normal distribution is about Z. We always calculate the Z value. So there's the formula. Z is equal to X minus mu over the standard deviation. We are going to calculate 30 first. 30, we are going to start with 30 minus, this is the mean, so the mean is 28, divided by the standard deviation. The standard deviation is 4. So Z is equal to 30 minus 28 over 4. Z is equal to 0.5. Z is equal to 0.5. z is equal to 0,5. Now let's go to 34. We're also substituting the formula. 34 minus mu, which is 28. Mu doesn't change, only the x changes. Now the standard deviation is 4, so the z value is equal to, so 34 minus 28 over 4 is equal to 1,5. 1,5, so z is 1,5. Then let's go to the next step. Now with 30, with the x value of 30, we got z of 0,5. So we're going to substitute 30 by 0,5. Then the signs are still the same, but we change x because we no longer have x. We calculated z, so this x changes to z because these are the z values. So the z value of 34 is 1,5. Then go to the next step, which is drawing the normal distribution curve like this. This is equal to 1. This normal distribution curve, this is the normal distribution curve. It is equal to 1. The total of this curve is equal to 1. This side equals to 0,5. This side is equal to 0,5. So 0,5 plus 0,5 is equal to 1. Now, with the x value of 30, we use the x value of 30 and we got z, which is 0,5, and 0,5 is positive. This side is the positive side, and this side is the negative side. So all the negative numbers are in this side and all the positive ones are in this side. So in the middle is 0, but we're going to start by the mean. The mean is 28, so in the middle is 28. So by the x value of 30, we got 0,5. 0,5 is positive, so we can estimate 30. Maybe 30 is here. This is 28, so maybe 30 is here, somewhere here. Then maybe 34 is here. So actually here is 0. Is 0 in the middle. These are the z values. Now the z value of 30 is 0,5. We got 0,5. So the z value of 34 is 1,5. These are the z values. In the middle is 0. Then by 30 we got 0,5. By 34 we got 1,5. Now we're going to check the probabilities of these z values on the normal distribution table. On the normal distribution table, there's the standard normal distribution table, which is the Z table. So we are going to check 0.5, the probability of 0.5. There's Z on this table. Then let's go to 0.5. There's 0.5. So the probability of 0.5 is 0.1915. 0.1915. 1915. Then the probability of 1.5, go to the Z table, check 1.5. There's 1.5. So the probability of 1.5 is 0.4332. 0.4332. Now we want the probability of between 34 of 30 and 34. What is the probability that it will last between 30 and 34 months? So between 30 and 34 months, there's the area between 30 and 34. So you are going to shade between 30 and 34. We are going to shade between 30 and 34. Now, we want this area or this probability that is between 30 and 34. So in order to get it, we're going to subtract this one from this one in order to get the probability that is between. The probability that is between. So we're going to subtract this one from this one. 0.4332 minus this one, 0.1915 minus. So the probability that it will last between 30 and 34 months is 0.2417. 0.2417. 0.4332 minus 0.1915 is equal to 0.2417. Like that. That was question A. Now, question number B. What is the probability that a randomly selected battery will fail within 2 years? Will fail within 2 years of the date of purchase. Within 2 years of the date of purchase. So we are using the same formula because we are going to calculate Z. So P into within 2 years. which means from 0 up to 2 years. From 0 up to 2 years. Now, the life of this battery is normally distributed in months. So the mean is calculated in months and the standard deviation is calculated in months. But the question says we must calculate the probability that at random selected the battery will fail within 2 years. Within 2 years. But the mean and standard deviation is in months, which means we must change that 2 years into months. So a year is equal to 12 months. So 12 plus 12 is equal to 24. So we are going to calculate the probability that it will fail in 24 months, which is 2 years. 2 years is 24 months. Now zx minus mu is equal to over the standard deviation, then is equal to, now within 2 years, which means between 0 and the 24 months. 24 months is 2 years, so we cannot calculate 0. 0 is 0. So we are going to calculate 24. So x is 24 minus mu. Mu is the mean, which is 28 months. It doesn't change. Divide by the standard deviation, which is 4. Doesn't change. So the z value is equal to 24 minus 28 over 4. So the z value is minus 1. Minus 1. P into minus 1 is less than z, and z is less than 0. So you always start with the negative number. Always start with the negative number. Because negative 1 is less than 0. Negative 1 is less than 0. 0 is more than negative 1. That's why we said minus 1 is less or equal to z, and z is less or equal to 0. So in the middle, it's 28. So by 24, we got a negative value, which is minus 1. So we're going to put 24 on this side, because the z value of 24 is negative. So this side is for the negative values. 0 in the middle. So we got negative 1. Within 2 years or within 24 months. So we are going to shade here between 0 and this negative 1. So we are going to the normal distribution table and check for negative 1, the probability of 1, of negative 1. So in this table there are no negative values, so we are going to take 1, 0. 1, 0 is 0,3413. 0,3413. So 0,3413 is here. 1, 3. So the answer is 0,3413. Just like that. That was question number B. Now let's go to the last question. Question C. Question C. What is the probability that a randomly selected a battery will last more than 1.5 years? More than 1.5 years. Now, more than 1.5 years. A year is equal to 12 months. Now, half year is equal to 6 months. So 12 plus 6 will give you 18 months. So we are calculating the probability that the battery will last 18 months. So P will last more than 18 months. So X is more than 18. This is more than. So 18 months is equal to 1.5 years. The formula is the same, X minus mu over the standard deviation. So X is 18 minus mu is 28 over 4. So the Z value is equal to 18 minus 28 over 4, which is equal to minus 2,5. The Z value is minus 2,5. So the next step is equal to Z is more than negative 2,5. Negative 2,5. We're changing X to Z, 18 to negative 2,5. So the following step is to draw the normal distribution curve. In the middle, it's 28 months. Then 18 months is less than this 28, which means it is negative because we got the negative Z value. So 18 months maybe is here. Zero, always 0 here in the middle. Then we put negative 2,5 here. So the question says more than 18 months. So this is 18 months. So the part that is more than 18 months is all this side. From here up to here, this is more than 18. this is less than 18, but this is more than 18. So we are going to check this part, the 18 part, from the normal distribution table, which is the Z table. So what is the probability of that part or of that area? So we're going to check 2,5 because there are no negative values here. There's 2,5. So it's 0,49379, 0,49379, 0,49379. This side, I think I said in the beginning of this video, this side is equal to 0,5 and this side is equal to 0,5. But this part only, this one from here up to here, from 18 to 28, is 0,49379. But this side, all this side is 0,5 and all this side is 0,5. But this part from here up to here is 0,49379. So this side is 0,5. Now we want all the side that is greater than 18. So we're going to add these values to get all this part that is more than 18. 0,5 plus 0,49379 is equal to 0,5 plus 0,49379 is equal to 0,99379, 0,99379. Like that. I think my work here is done. Until next time, bye.